In this video, we're going to learn the rules of significant figures. To first understand significant figures, we must learn the rules. One of the first rules is that non-zeros and zeros and between other non-zeros count as significant figures. Let's look at an example where this rule applies. Let's say we have 704.001. So if we read the rule again, it says non-zeros and zeros in between other non-zeros. So if we were to count up significant figures, we would see that we have a non-zero here and zeros in between another non-zero. So these zeros are going to be considered significant figures. For this number, we're going to have 1, 2, 3, 4, 5, 6 significant figures. So another rule that applies to significant figures is that leading zeros do not count as significant figures. So this means do not count the leading zeros before the first non-zero number. So let's look at an example where this rule applies. We have 0.00600. And if we were to count the significant figures, we are not going to count the leading zeros. So our leading zeros in this case are going to be our 0 before the decimal and our 2 zeros after the decimal, just before 6. If we were to count the significant figures in this example, 1, 2, 3, 3 significant figures. The last rule we must know about significant figures is that trailing zeros are significant if there is a decimal place in front of the trailing zeros. However, if there is not a decimal place, trailing zeros are ambiguous and should not be counted. So let's look at a few examples that may apply to this rule. The number 380 with a decimal point at the end. So we're going to count the trailing zeros since there is a decimal place. So in this case, we're going to have 1, 2, 3 significant figures. In this case, we have 3 significant figures because with the decimal point at the end of the 0, it shows that this 380 was measured to the nearest ones place. Therefore, we have 3 significant figures. Let's look at another example. Let's say we have 11.0, and we were to count the significant figures. If a number has a 0 after the decimal point, the 0 counts as a significant figure. So in this case, this example will have 3 significant figures. So let's get an example that looks at the second part of this rule. If there is not a decimal place, then the trailing zeros are ambiguous and should not be counted. So if we have a large number like 36,000, and we were to count the amount of significant figures, if we only count the non-zeros, this example has 2 significant figures. The trailing zeros aren't counted as significant figures, so we're going to assume that our precision was to the thousandths place. Therefore, we have 2 significant figures. When dealing with multiplication and division and trying to keep track of our significant figures, the limiting significant figures will be the number that has the least amount of significant figures in it. So if we were to look at an example, say we have 3.26 times 4.5. If we were to calculate this out, we would get an answer of 14.67. And if we were to limit it to 2 significant figures and we were to round up this 10th place, our final answer would be 15 as a final answer. When dealing with addition and subtraction, we limit the significant figures to the number that has the least precise measurement. So an example here would be if we had 5.365 minus 1.45, we would get an answer of 3.915. So now we're looking at which number is least precise. So this goes out to the thousandths place, and then this number only goes out to the hundredth. So we're going to limit our answer, if we're keeping track of significant figures, to be 3.92, since we are only going out to the hundredths place. If we were to look at one more example, we did addition this time. If we added these two numbers together, we would get a value of 487. So in this case, we're going to look at the least precise number, which in this case is a 7, is measured to the ones. So if we were to keep track of significant figures, our final answer would be 490. So here we have a few examples to practice the rules we just learned about significant figures. So the first number we have is 600. If we were to count the significant figures, we would see that we would not count the trailing zeros since there's no decimal point. For 600, there's only one significant figure. This example here is written in scientific notation as 6.0 times 10 to the fourth. Or if we expanded it, it's 60,000. If we were to count significant figures, we would see that we have a non-zero and then a zero after the decimal point. So in this case, we have two significant figures. And this one we have no zeros to worry about, so we're going to count all non-zeros. So in this case, we have 1, 2, 3, 4 significant figures. In this example, we have 40.5. We're going to count the zeros in between our non-zeros, and then we're also going to count the zero after the 5, because it shows that our measurement was taken at least to the hundredths place. For this example, we have 4 significant figures. In this example, 0.0105. First, find the first non-zero, which is our 1. And since we have leading zeros, our leading zeros are not going to count as significant figures. So starting at 1, we have 1, 2, 3 significant figures. For this example, we have 650 to a decimal point. Since 650 has a decimal point, we can assume that the measurement was taken to the ones place. This example would have 3 significant figures. And our last example is 15. We look at our non-zeros, a 1 and a 5, and then we have a decimal point and 2 trailing zeros after the decimal point. According to Rule 2, this example has 4 significant figures. So let's do some multiplication, division, subtraction, and addition problems to see if we can keep track of our significant figures. So in this example, we have 5.45 times 1.2. When we multiply this out, we get 6.54. However, since we are multiplying, we only keep the number that has the smallest significant figures. So in this number, we have 3 significant figures, and this number has 2 significant figures. So our final answer for this example is going to be 6.5. If we do a division problem, the same rule applies. We take the number that has the least amount of significant figures, which in this case is 21. If we divide this out, we'll get 21.71. Since we're only keeping to 2 significant figures, our final answer will be 22. For subtraction and addition, we look at the number that has the least precise measurement. So in this case, the least precise measurement goes to 4.3 since it's only measured out to the tenths place. So if we were to subtract these two numbers, we would get 3.56. And since this only goes out, 4.3 only goes out to the tenths place, our final answer is going to be 3.6. After we round our 6 up. In the last problem, we're going to add 12 plus 2.45. So once again, we're going to look at the number that has the least precise measurement. In this case, 12 only goes out to the ones place. So if we were to add these up, we would get 14.45. But since our most precise is in the ones position, our final answer is going to be 14.